Section 5.3, the sum and difference identities for cosine. These are the sum and difference identities for cosine. We can use these identities to help us determine exact values of degrees and radians that are not common degrees and radians. Our common degrees and radians we know are 30, 60, 90, 45 degrees. These will help us determine ones that are not of those common degrees or radians. So here I have cosine A minus B equals cosine A cosine B plus sine A sine B, and the sum identity is cosine A plus B equals cosine A cosine B minus sine A sine B. Let's take a look at an example. Here I want to use the identities to find the exact value of cosine of 15. This is not one of our common degrees that we use on our unit circle, but we can achieve that common degree by using our unit circle values. For example, I can achieve 15 by taking cosine of 45 degrees minus 30 degrees. 45 degrees minus 30 degrees is our 15 degrees, and we can determine our values for 45 and 30. And this would be A, and this would be B. Now I just substitute into my difference identity. That gives me cosine of 45 times the cosine of 30 plus the sine of 45 and the sine of 30. And from our unit circle values, I can find the values of cosine and sine 45 and cosine 30 and sine 30. We know from our unit circle cosine of 45 is the square root of 2 over 2 times cosine of 30 is the square root of 3 over 2 plus the sine of 45 is the square root of 2 over 2, and the sine of 30 is 1/2. Then I can simplify. Square root of 2 times the square root of 3 is the square root of 6 over 4 plus square root of 2 times 1 is the square root of 2 over 4. We have common denominator, so I can combine the numerator. That's the square root of 6 plus the square root of 2. They're not like terms. All over 4. Again, I want to find the exact value using identities. Here I have cosine 5 pi over 12. I can break that into values that I know from the unit circle, which would be pi over 6 plus pi over 4. That would give us 2 pi twelfths plus 3 pi twelfths when I find a common denominator. And of course, when I find the sum of those, I'm going to get 5 pi twelfths. Now I can use my sum identity for cosine and find the exact value. That's going to give me, when I label this A and that angle B, cosine of pi sixth and cosine pi fourths minus sine of pi sixth and sine of pi fourths. And we can find the value of each of these to determine the exact value of cosine 5 pi over 12. Cosine of pi over 6 would be the cosine of 30, which would give us the square root of 3 over 2, times the cosine of pi fourths is cosine of 45 degrees, which is the square root of 2 over 2, minus the sine of pi 6, or the sine of 30, is 1/2. And the sine of pi fourths, or 45 degrees, is the square root of 2 over 2. Now I can simplify and get the square root of 6 over 4 minus the square root of 2 over 4. And when I combine, that's going to give me the square root of 6 minus the square root of 2 These are not like terms, all over the common denominator of 4. Again, I want to find the exact value using identities. Here I'm given an expression that matches one of my sum or difference identities for cosine. And if I match it up, it matches up with the sum identity of cosine A plus cosine B. And in that case, 87 would be angle A and 93 would be angle B. Now I can just compress this expression into cosine A plus B, which in this case would be cosine 87 plus 93. And when I simplify, that's going to be cosine of 180. And from our unit circle, we know the cosine of 180 is a negative 1. So we want to use identities to find the exact value. Again, we're given an expression that we can use one of our sum or difference cosine identities to solve. And this expression matches our cosine sum identity. And we can identify angle A, angle B. And when I compress that into cosine A plus B, I will have cosine pi sixth plus pi thirds. And when I simplify, that's going to be cosine. And this would be a common denominator of 6, so that'd be 2 pi 6, which would give me 3 pi 6, or also cosine of pi over 2. And we know that the cosine of pi over 2 in our unit circle is 0. And these are our cofunction identities. Sine of theta equals cosine 90 minus theta, cosine theta equals sine 90 minus theta, and cotangent theta equals tan 90 minus theta. And they also can be written in this fashion. We also have similar identities that can be obtained for a real number domain if we replace 90 degrees with pi over 2. Here's our first example. Write each function value in terms of the cofunction of a complementary angle. I'm given tangent of 56, and I know I can write that as tangent theta equals cotangent 90 minus theta. So tangent of 56 equals cotangent of 90 minus theta. And here theta is 56 degrees. And when I simplify, that's the cotangent of 34. Our next example, again, find the function value in terms of the cofunction of a complementary angle. I have cosecant of 5 pi over 8. And cosecant can be written as cosecant theta equals secant of 90 minus theta. So I can just write secant of 90 minus theta, which is 5 pi over 8. But recall, I can change this 90 into pi over 2. So that gives me secant of pi over 2 minus 5 pi over 8. To simplify, just find a common denominator, which is going to be 8. Multiply the top and bottom by 4. Gives me 4 pi over 8 minus 5 pi over 8. And when I simplify, that gives me the secant of a negative pi over 8. On this example, I want to find an angle theta that makes each statement true. I'm given that sine negative 30 degrees equals cosine theta. I know that cosine theta is equal to sine 90 minus theta. So I can write this as sine negative 30 degrees equals cosine, which I know is sine 90 minus theta. Now I know that these two values must be equal, so I can set them equal. Negative 30 equals 90 minus theta. When I solve, I get a negative theta equal to a negative 120. And when I simplify that, theta is going to equal 120 degrees. Again, I want to find an angle theta that makes each statement true. I have cotangent theta equals tangent of 125. I know that cotangent equals tangent of 90 minus theta. Now I know that these two values must be equal. So 90 minus theta equals 125. Negative theta equals a positive 35 degrees. And when I solve that, theta equals a negative 35. Again, I want to find an angle theta that makes each statement true. Here I have cosecant 3 pi over 4 equals secant theta. I know that secant theta is equal to cosecant 90 minus theta. Therefore, I can rewrite this as cosecant 3 pi over 4 equals cosecant 90 minus theta. Then I know that these two values are equal. So I have 3 pi over 4 equal to, and instead of 90, I'll put pi over 2 minus theta. Subtract pi halves from both sides. That gives me 3 pi over 4 minus pi over 2 equals a negative theta. And when I simplify, common denominator is going to be 4, so multiply by 2 over 2 gives me 3 pi over 4 minus 2 pi over 4, which is equal to pi over 4, equal to a negative theta. And when I divide by a negative on both sides, gives me theta equal to a negative pi over 4. On this example, we want to use identities to write each expression as a function of theta. Here I'm given cosine of 180 minus theta. To solve this, I can use our sum or difference identities for cosine. Here I can use the difference identity. Therefore, I know that this is my angle A and this is B. That gives me cosine of A to be 180 times cosine of B, which is theta, plus sine of A, which is 180, times sine of B, which is theta. Now I can just simplify. Knowing my unit circle, I know cosine of 180 is a negative 1. Cosine of theta plus the sine of 180 is 0. Sine of theta. And when I simplify, this gives me a negative cosine theta, because 0 times sine theta is 0, and when I combine, I have my solution, negative cosine theta. Again, using identities to write each expression as a function of theta. Here I'm given cosine 270 plus theta. I can use our sum identity for cosine to simplify this problem. So I have 270 for angle A and theta for angle B. And I just substitute into cosine 270 cosine theta minus sine 270 and sine theta. And I know from the unit circle that cosine 270 is 0 times cosine theta minus sine of 270 in the unit circle is a negative 1 sine theta. And then when I simplify, 0 cosine theta is 0. And a negative times a negative 1 is 1 times sine theta, which is just sine theta for my solution. On this example, I want to find the cosine of s plus t and cosine of s minus t. To do that, I'm using my sum and difference identities for cosine. And instead of using a and b, I'm using s and t. S represents angle A and t represents angle B. To do that, I need to find the cosine of A and B, so therefore I need to find a cosine of S and T, and the sine of A and B, or the sine of S and T. I'm given the sine of S to be 3 over 5, which really is y over r. So in quadrant 2, my triangle would look something like this. Y is 3 over r, which is 5. I can determine by the Pythagorean theorem, or a triple, that my x value is 4. But being in quadrant 2, it's a negative 4. So I have sine of S equal to 3 over 5, or cosine of S equals a negative 4 over 5. And for my cosine of t, I know is a negative 12 over 13. And that drawn in my second quadrant would look something like this, which would give me a negative 12 for my x value, and my r is 13. By the Pythagorean theorem, or my triples, I know that this is 5. So my sine of t is equal to 5 over 13. Now I just substitute in cosine S plus t is equal to cosine A cosine B. Cosine A would be S, which is a negative 4/5. Cosine t is a negative 12/13. Minus sine S, which is 3/5, sine B, which is 5/13. And when I simplify, I'm going to get negative 4 times a negative 12 is a positive 48, and 5 times 13 is going to give me 65, minus 3 times 5 is 15, 5 times 13 is 65, and when I simplify, 48 minus 15 is going to be 33 over 65. Now I need to find cosine S minus t. To do that, I'll use my difference identity. So I'm going to need cosine A, which is cosine S, which is a negative 4/5. Cosine B, which is a negative 12/13, plus sine S, which is 3/5, sine B, which is sine t, which is 5/13. Let's simplify. Negative 4 times negative 12 is a positive 48. 5 times 13 is 65, plus 3 times 5 is 15, over 5 times 13, which is 65. I need to find their sum, which is going to give me 63 over 65.